Hello, I'm Mrs. Stevenson. Half-life. An atom's half-life is the amount of time it takes for half of the atoms in a sample to decay. So if we start out with 100 atoms of our initial material, which can also be described as the parent material, and we go through one half-life, we only have 50 atoms of our parent material left over. The other atoms have decayed into daughter atoms. If we go through another half-life for a total of 2 half-lives, from our 50 parent atoms, we will only have 25 parent atoms remaining. And again, if we keep going down one more half-life, you would have to take half of your 25 parent atoms, which is actually 12.5 atoms. But we're not going to have half of an atom. It would be something close to 12.5. Now you can actually calculate an atom's half-life by using the following equation. You have your remaining, which are the amount of parent atoms you have remaining, equals your original, which was the original amount of parent atoms you have, times 1/2 to the power of t. Okay, and that t represents the number of half-lives that passed. So, for example, if we had an original sample of 200 atoms, and we had 75 atoms remaining, we could determine how many half-lives have passed in this situation. We're going to plug our original values in and our remaining values in to see that 75 is equal to 200, both of those are atoms, times 1/2 to the power of t. Well, we're going to try our best to get this t by itself on one side of the equation, so we have to first divide both sides by 200 atoms, so that it cancels on the right. So we are left with 75 atoms over 200 atoms equals 1/2 to the power of t. Now, because our variable is in the exponent, we have to use the natural log. So we have to take the natural log of both sides of our equation. So we have the natural log of 75 divided by 200 is equal to the natural log of 1/2 to the power of t. When we take the natural log of both sides, we see that, well, we're first going to keep our natural log of 75 over 200, and taking the natural log of 1/2 to the power of t, we get an answer of a negative 0.693 t. This takes the t out of the exponent and brings it down. If we take the natural log of 75 divided by 200, you find that you get a negative 0.980, and we set that equal to what we had before, a negative 0.693 t. We're still trying to find t and get it by itself, so we're going to divide both sides by a negative 0.693. So we have them canceling on the right. We have a negative divided by a negative, which cancels and makes a positive. So we get a final answer of t equals 1.42 half-lives. So 1.4 half-lives have passed.